If you want to subtract fractions, first, you must understand them and know all the parts. We can't talk about fractions unless we can talk about fractions. So let's go over some of the vocabulary words. This is a fraction. The top number is called a numerator, and the bottom number is called a denominator. It's an amount that is less than 1. And if an amount is less than 1, but more than 0, we say that it's a fraction. This number here is also a proper fraction. Both of these have a smaller number on top and a larger number on the bottom. Both of these numbers are smaller than 1, but bigger than 0. Now this number here is a mixed number. This number is actually bigger than 2, but less than 3. It's got a whole 2 in it, and then like a fraction of 3. So it's almost 3, but not quite. So we call it a mixed number. And sometimes you get weird stuff like this. If the same digit is the numerator and the denominator, that's kind of weird. Most people don't say, I have 7 parts out of 7. I have 30 parts out of 30. Like, that's just, nobody talks like that. What we do is we say, that's not a fraction at all. That's actually an integer. And then we have this weird thing. See how the bigger number is on top this time? That's improper. It's improper because if I have something and I cut it into 3 pieces, and then I have 6 of those pieces, like that doesn't make sense. So what most people do is they say, oh, this is 2. And this guy, this is just a complicated guy right here. There's nothing wrong with this. It's technically proper, but it's not really the simplest form. Some people call it simplest form and some people call it reduced fractions. There's a lot of things that you could call this. And honestly, that's the hardest part about fractions. There is 1,000 ways to write them. In fact, there is an infinite number of ways to write 1/2. You could say 2/4. You could say 12/24. You could say 51/100. It gets kind of ridiculous though when everyone is answering a problem and they all have different denominators and therefore different digits to represent the answer. So some people say, just give me the lowest common multiple. Just give me the lowest common denominator. Just give it to me in the simplest way with the lowest numbers. Sure, it makes it simpler for everybody. So now that we got our vocabulary out of the way, let's take a look at this number. This is 2 1/3. It looks like this. 2 circles and 1/3 of another circle. Now look at this number. The 4/3 part is definitely improper, but it looks like this. You see how I have 6 whole circles and then 4/3 colored in? Let's count them. And here's my thirds. I have 1/3, 2/3, 3/3, 4/3. So it's almost like I have a picture of 6, and then a picture of 3/3, and then a picture of 1/3. So I might as well just say I have 7 whole circles and then 1/3 of another circle. See how a mixed number kind of helps me understand a little more? But that's the thing about fractions. You can manipulate them whatever you want. So in order to understand how to subtract fractions, which is what we're doing today, you have to know how all the parts relate to each other. How the numerator relates to the denominator, how the denominator relates to the whole, you got to understand all this. And then we can do the subtracting part. When we're talking about subtracting, in order to subtract fractions, you have to know your multiplication tables real easy, real fast, real fluent. Let me show you what I mean. Take a good look at this multiplication chart and see if you can find all the number 8. Go ahead and try to find them. Okay, so if I asked you, what are the factors of 8? You could easily tell me, oh, 4 and 2, and 2 and 4, and 1 and 8. Okay, those are all the factors of 8. Good job, right? So now do me a favor and see if you can find all the number 36s. And there's a bunch of them. Go ahead and see if you can find 36. So now if I asked you, hey, what are the factors of 36? You could tell me 12, 9, 6, 4, 1, 36. Starting to see a pattern here? So let's just take a closer look at one small portion of the multiplication tables. Now, if I showed you 3 fractions, 2/3, 1/21st, 1/21, I don't even know how to say that, 1 to 21, and 5/18, and I asked you, what do all these denominators have the same? You might be a little confused. You'd say they have nothing the same, but they do. Look closely at this multiplication table and tell me, is there a row that has a 3 and a 21 and an 18 in it? Is there one row that has all that? Yeah, there is, right here. Which means all of the denominators have something in common. They have a 3 in common. They're all divisible by 3. So knowing that they're all divisible by 3 makes this subtracting fractions thing a whole lot easier. Because then I can say 2/3 is the same as 4/6, which is the same as 6/9, which is the same as 8/12. You see how I can go on forever with this? So I could change 2/3 into anything that makes my life easier. I can change the numerator and the denominator all I want, as long as the ratio between the two stays exactly the same. The ability to change fractions quickly and easily depends on how well you know your multiplication facts and how well you can see the pattern. So now we're just about ready to subtract them. When we are adding or subtracting fractions, it's easiest when you have the same denominator. That's how we've been teaching the kids to do this for the last hundreds of years. It's not the only way to do it, but it's literally the easiest way. Let me show you what I mean. Here is 2 and 2/9. I'm going to subtract 1 and 1/9 from 2 and 2/9. So here is 2 circles and 2/9 of another circle. If I want to take away 1 and 1/9, I just take away 1 and then 1/9, and then I count what's left over. I have 1 and 1/9 left over. So let me show you that using the standard algorithm. So 2 and 2/9 minus 1 and 1/9 equals 1 and 1/9. Watch that. So 2 minus 1 gives me that 1. And 2/9 minus 1/9 gives me that 1/9. You see that? That's the standard algorithm. Notice how the denominators stay exactly the same throughout the whole problem. If I start off then with 2 and 2/9, but I need to subtract 1 and 1/3, things get a little more complicated. But if I look at the denominators and I see something they have in common, it gets a little bit easier. So what do 3 and 9 have in common? Well, I know that 3 times 3 makes 9. So I bet you they have a 3 in common. 3 3s make a 9. So I'm going to keep 2/9 the same, but then I'm going to change 1/3 into 3/9. Because, well, 3/9 is the same as 1/3. So if I want to do the standard algorithm, I'm going to take the 2 minus the 1, and then I get this 1. And then I'm going to take 2/9 minus 3/9 and get, wait, I can't do that. So the standard algorithm doesn't work here. I'm going to have to get a little creative. Okay, watch what I do on this problem. You see where I got those extra 9s from? Now I take that whole thing and I say, okay, I'm just going to call that whole thing 20/9. Now I'm going to subtract 1 and 3/9. But that 1 and 3/9 still don't work, right? So now I'm going to say, I'm going to call that 12/9. And now I can solve the problem. I want you to try to make sense on your own now. I want you to try a problem that I'm going to give you. I'm going to give you a subtraction problem, and I'm also going to give you the answer. Because I want you to try to figure out how to subtract fractions. I want you to try to figure out all the missing steps. Here is the problem I want you to do. 2 and 1/2 minus 1 and 5/9. The answer is actually 17/18. That's the answer I got. What I want you to do is I want you to try to explain how that works. There's nothing wrong with my logic. This answer is actually correct. I'm just missing the steps to get there. How did I get the 18? How did I change the denominator? What did I change the numerator to? Like, there's lots of details that are missing. Your assignment then, after watching this video, is to try to figure out how this is true. That means I want to see your proof of every step. I'm going to be very skeptical, and I'm going to be saying, I don't understand this. How does this make sense? Why did you do this? Why is this here? How'd you change the 9 to 18? How'd you change the 2 to 18? And see if you can understand it. When I look at your paper, I want every step to be crystal clear. And here's the thing. There's really no nice and easy way to understand how to subtract fractions. It's one of the hardest things that we teach. And every teacher has their own way of subtracting fractions, and I want you to figure out your way. When we meet, you'll be listening to your classmates and all the different ways that they figured out how to get 17/18 for the answer. Because I know you are the kind of person who can do hard things. And this will definitely be a test of that. Good luck.